It is possible to change the pressure and volume of a gas without affecting its temperature in a gas column. This is what a simple gas column would look like. Here, the bottom of the column is filled with oil, which is used to trap the air in the rest of the column above. Then we can change the volume of the gas by pumping more oil into the column. By using this method, we won't affect the temperature of the air directly or indirectly, but it will be compressed and decrease in volume as the oil takes up more space in the column. We can then study how the pressure of the air has changed. Though another way to think of this is that by pumping the oil, the force pushes it against the air, so the air has to change its pressure to balance this in some way. But why would there be a relation between the volume and pressure of a gas? Well, first, if the volume of a gas is reduced, then the particles have to travel a shorter distance between the walls. Let's take a closer look at the air in the column, with the oil at two different levels. Remember that gases, like air, consist of molecules that move around a container randomly. So as we can see, when the oil is low and the air takes up a large volume, there is a long distance the air would have to travel between the oil and the top of the column. Then when the oil is higher, this distance is shorter. This means collisions with the walls happen more frequently. Remember that air molecules will change direction after hitting a wall. And since there's less distance they can travel in a straight line when the volume is smaller, these collisions will happen more frequently. Also remember that the pressure from the gas is found by adding up all the forces from these collisions. So if there are more collisions, there are more forces. But what else about these forces would change? The outward force from the gas is also spread out over a smaller surface area. So notice here that when the oil is low, there is a large surface area that the air molecules can collide with. And when the oil is high, this surface is smaller. In general, decreasing the volume of a container will also decrease its surface area. Therefore, the pressure of the gas increases. This is because pressure is equal to force divided by area. So when we decrease the volume, there is a greater force from the more frequent collisions and a smaller area, meaning there is a greater pressure. This also means that if we increase the pressure of the gas without changing its temperature, then the volume of the gas would have to decrease. So what about if we do the reverse? Well, if the volume of a gas is increased, then the pressure of the gas will decrease. Let's now imagine we did the opposite and lowered the oil level in the column, so the air expands and takes up a larger volume. Now there will be less collisions between the molecules and the walls, and the forces from these collisions will be spread out over a larger surface. Together this means the gas exerts a smaller pressure. And again, we can also think of this as the gas having to take up a larger volume if its pressure decreases. But how can we confirm this relationship is correct? Well, we can observe this relationship by taking measurements when changing the gas volume at a constant temperature. So in the gas column, we can use a pressure gauge to determine the pressure the air must be exerting on the oil, which would be the same pressure the gas exerts in all directions. Then we can work out the volume of the air by measuring the length of the column it occupies. Remember, it's important that we use this method to change the pressure and volume, since the temperature of a gas also affects its pressure. So we need to make sure that it's kept constant. So once we've taken multiple readings from the column, we can use it to plot a graph relating pressure and volume. If the pressure hasn't changed, it should be a curve like this. showing us that when the pressure increases, the volume of the gas decreases. For your exams, make sure you can recall and sketch this graph, as well as explain what it shows and the reasons for this relation.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!